In this video, we're going to continue on with our inverse trig functions. And here we're going to focus on compositions of trig functions with inverse trig functions that aren't the same. So in the last video near the end, we talked about, well, not near the end, throughout, for sine, cos, and tan, we talked about what happens when we compose sine with sine inverse, or cos with cos inverse. But here we might compose tan with cosine inverse. Okay, so now you have two different trig functions, so one being an inverse and one not, composed together. Okay, so that's what we're going to look at here. So I'm going to go through this example in detail. So here we want the exact value of tan of cosine inverse of 4 over 5. Okay, so we don't want to just use our calculator because we want the exact value. So we want tan of this angle. Okay, so what we're going to do is we're going to let theta be that angle. So cosine inverse of 4 over 5. So that means that cosine of theta is equal to 4 over 5. Okay, so theta must be in quadrant 1. Okay, now nice, it gives me a y here. So we know that the range of cosine inverse of x is 0 to pi. That's the domain that we had to restrict cosine to. Okay, so that's quadrant 1 or 2. Okay, and in quadrant 1, we have cosine of x is positive. Okay, whereas in quadrant 2, it's negative. Okay, it would be negative. So that's why we have to be in quadrant 1, because it's positive. And we know it has to be in either quadrant 1 or quadrant 2. Okay, so now, using the definition, cosine is the adjacent over the hypotenuse, we can draw a triangle, right? We did this ages ago. So when cosine is, so we have cosine of theta is 4 over 5. That gives us a triangle. That's not a very good triangle. Let me try that again. Okay, that's better. So we have a right angle here. So let's call this one theta. So this is the hypotenuse side. This would be the opposite for theta, and this would be the adjacent. So if I make it so that it's cosine is the adjacent over the hypotenuse, I'm going to call this side 4 and this side 5. And then to find this side, it would be the square root of 5 squared minus 4 squared, which is the square root of 25 minus 16, which is root 9. So that side would be 3. Okay, so that side's 3. So here we don't even need to find cosine inverse of 4 over 5. Because now we know we want to find tan of theta. So we can use this triangle instead to find tan of theta. Okay, so tan of theta is the opposite over the hypotenuse, or sorry, the adjacent for tan. Okay, so that's going to be 3 over 4. Now it has to be positive. Okay, since we know that theta is in quadrant 1. Okay, so it's going to be a positive number. So we know it has to be 3 over 4. Okay, so then I can conclude, because theta was cosine inverse of 4 over 5, then tan of cosine inverse of 4 over 5 is 3 over 4. Positive 3 over 4. So notice here, we did not need to determine the inside function, so cosine inverse of 4 over 5 in order to find tan of that value. Okay, so it was unnecessary because all we needed to know was this triangle. So that cosine inverse of 4 over 5 is related to this triangle, where our theta is the angle, and then we can find tan of it. Okay, so I'm going to leave 2 for you to try. Okay, you want to use a similar method. So 2 and 3. I will cover them in a subsequent video. It's also possible, though, that maybe the inside thing we do know. Okay, so it's possible that we actually know the exact value of the inside function, and then you can use that instead to be a bit faster. Okay, so for instance here, cosine inverse of 0 equals x means that cos of x is equal to 0. Okay, well, I know where cos of x is equal to 0. Okay, I should say and x is in, I shouldn't use that symbol. Okay, in the interval from 0 to pi. Okay, that means that x has to be pi by 2. Okay, so then I know that, so tan of cosine inverse of 0, that's actually tan of x, and I know that x is pi by 2. Okay, now tan of pi by 2, that's sine of pi by 2 over cos of pi by 2, that doesn't actually exist. Okay, so here this thing doesn't exist, but if it was a nice number, okay, then you just compute tan of it. So it could be that you have it the other way around. So here I have the inverse trig function on the outside and the trig function on the inside. So I want tan inverse of cotan of 2 pi over 3. So here it's a bit more simple. So if you just go to degrees, so again we want the exact value. Okay, so 2 pi over 3 radians. So I'd want to times that by 180 over pi. If I do that, I'm going to get 120 degrees. Okay, then I can calculate the expression in degrees. Okay, so tan inverse of, not cos, cotan of 120 degrees is tan inverse of 1 over tan of 120 degrees. Okay, if I compute that, I get negative 30 degrees. Okay, so now I just convert that answer back to radians. So negative 30 degrees is negative pi by 6 radians. Okay, so that tells me that tan inverse of cotan of 2 pi by 3 is actually negative pi by 6 as its exact answer. Okay, so you can always do it that way as well, for the inverse trig function on the outside and the cotan, or the trig function on the inside. So you just compute the inside one in degrees and then take the inverse of it, the other trig function in degrees. If it's a nice number, then you can convert that to radians.